Hello, college biology. This is our third video over the basics of chemistry, and we are going to review atomic structure and explain it. So let's dig in. This is a model of a nitrogen atom, and I'm covering up one of the electrons. Going to move myself. There we go. And atoms have two primary regions. They've got our nucleus, and they've got our electron cloud that surrounds the nucleus, and within the nucleus we have two of our subatomic particles. We have our protons and our neutrons, and within the electron cloud we have our electrons. And though this is a very common model, it is inaccurate for some reasons. They do a pretty good job showing that there are things that are covering up particles in the back here in this nucleus, but it's still a two-dimensional representation of a three-dimensional object. So that's one of the failings. And another is that these rings kind of indicate that the electrons orbit in circles, but that's not at all true. The electron movement is very irregular, and it will ziggle-zag around. So these electrons are actually going in really crazy, wild, irregular shapes. And that's actually something that we can explain. So let's start explaining this model. One, we know from electromagnetism that if we have two similar charges, they are going to repel from each other. So right away, the nucleus is kind of causes a problem because we have these particles in here that should be shooting out away from each other. So why aren't they? Well, that is the heroic role of the nucleus, where the nucleus can kind of separate protons from each other, reducing their repulsion, but more importantly, they exert what is called the strong nuclear force, which binds the protons and the neutrons together. So when atoms get quite large, they can be unstable because the neutrons don't actually exert enough force to keep the atom stable, and so you'll have radioactivity and particles from the nucleus will start jumping out. But for the most part, atoms are stable because the neutrons exert a strong nuclear force which holds the protons together even though they are positively charged and are repelling each other. So that explains the nucleus. Now we've got this electron cloud business. Well, we know that there are shells and there are different orbitals, and there are electrons. They start close to the nucleus, and then as we get more electrons, we form more orbitals that get away from the nucleus, and they get farther and farther out. So how do we explain that? Well, these electrons are negatively charged, and you would think that they would just try to stick to the protons, but because they constantly move, they never stop, and so they never stop. So even if they get close to the protons, they're going to keep moving away, and they'll ziggle-zaggle within their energy state, their prescribed energy state here, and so they'll rotate around trying to get close, but never quite reaching or stopping at the protons. And if there are two, that's fine. They can stay out of each other's way. This one will go over here, this one will go over there, and they'll zigzag back and forth, and they'll kind of avoid each other, and it'll be fine. But when a third electron comes, it wants in. Well, these guys are moving so fast, they're kind of streaking by constantly, so he moves by, he gets repelled back out, and then he wants to try again, but he gets repelled back out. He wants to try again, but he gets repelled back out. And so the later electrons end up being forced to a further shell or a further orbital because of the repulsion of the closer electrons. So now we get these shells forming, we get these orbitals forming. Now, because the shapes are influenced by the electron's tendency to be drawn toward the proton, but also repelled from other electrons, their paths are irregular, and we can kind of track where electrons are likely to be and determine what those shapes are. So these are the sort of shapes that electrons travel in. These are their orbital shapes. So there can be spheres, there can be these barbells as we add more, and they get more complex because the tension between being attracted to the protons but being repelled by other electrons forces them to travel in these oddly shaped clouds. And so that's all these oddly shaped clouds we're looking at. So what does it look like when we put all those together? Well, our atoms don't even look like rings at all. They look like these weird conglomerations of places where electrons can be. So if we've got this nucleus in here, this is what an electron cloud would look like. We wouldn't find electrons out here so much, but we would find them here and here and here, and we'd find them here and here and here. We'd find the closer electrons in the sphere and some that are in these barbells, and further electrons out here in these sort of like corner clouds, depending on how many protons there are and how many electrons there are. So the orbitals are very irregular. They're not like rings at all, but the rings are a convenient way to say how many electrons are close, how many electrons are far. So let's review. Protons and neutrons are in the nucleus, while electrons are found moving wildly in the surrounding electron cloud. To explain this, protons would repel from each other due to their charges, but are held together by neutrons, which separate the protons and hold the nucleus together with a strong nuclear force. Electrons are attracted to the protons, but do not stick to them like magnets due to their constant motion. And when new electrons approach the nucleus, closer electrons repel them further back. This cycles and repeats, so the further electrons attempt to reach the proton, the closer electrons continue to repel them, and the tension between the attraction and the repulsion results in the complex orbital shapes in the electron cloud. I hope this helps. Struggle well.